Hello, my name is Andrew Gary, and welcome to Seismic Sound Off, in-depth conversations in applied geophysics. In this episode, I speak with Dr. Xiaogui Miao on her 2021 SEG Honorary Lecture talk, From Multi-Component Imaging to Ocean Bottom Seismic Technology, Challenges or Opportunities. In this intriguing conversation, Xiaogui makes a convincing argument that utilizing multi-component imaging is a low-cost and low-effort option for companies to better discover oil and gas. She also discusses how utilizing multi-component technology is like moving from black and white images to color, and how recent advances in converted wave imaging have addressed long-standing challenges. This episode will challenge the status quo and help the geophysicists make a persuasive case to management to use multi-component imaging. This episode is sponsored by TGS. TGS offers a wide range of energy data and insights to meet the industry where it's at and where it's headed. TGS provides scientific data and intelligence to companies active in the energy sector. In addition to a global, extensive, and diverse energy data library, TGS offers specialized services such as advanced processing and analytics alongside cloud-based data application and solutions. For the full show notes and the link to register for free for Xiaogui's tour, visit seg.org/podcast. And now, our conversation. Thanks for speaking with me on your upcoming talk. And to help the listeners get started, if you could provide just a brief summary, and I'll give the title of your talk as well, of this talk, and it's called From Multi-Component Imaging to Ocean Bottom Seismic Technology, Challenges or Opportunities. So what could attendees of this talk expect in this lecture, in this talk?
I have been working on the multi-component and the OBS seismic imaging for more than 15 years. So in this lecture, I would like to share my experience and show what I have learned from the multi-component and ocean bottom sensor processing and imaging. I will briefly explain what are the multi-component and the OBS survey, and then we'll discuss some of the serious challenges. My special focusing will be on main challenges and the solution developed in converted wave imaging, such as near-surface S-wave velocity model building for shear statics and depth imaging, and also shear wave splitting analysis and compensation, and PPPS joint depth model building, and etc. I will also like to presenting what kind of opportunity and benefit of multi-component and the OBS technique can provide to us, so the people will be more interested in the technologies.
Yeah, I mean, you're saying those great words like solutions and opportunities, I'm sure that is getting people excited about this talk. And looking at the ocean bottom seismic technology, how important was the development of ocean bottom seismic acquisition to increase the interest from companies in particular in using multi-component imaging technology?
I think it's very important because actually that OBS acquisition has greatly pushed the multi-component technology move forward. Firstly, converted wave from the OBS survey can imaging through the gas cloud directly because it is not sensitive to the fluids. And the gas cloud and gas chimney always a troublesome problem in P-wave imaging, which can cause highly distorted P-wave imaging, resulted to a wrong interpretation, especially in somewhere the shallow gas clouds existed. That's one of the main reasons, I think, why the oil company are interested in the OBS, and multi-component acquisition. Another reason is there is almost no actual cost for OBS acquisition from 2C PZ only to 4C XYZ plus hydrophone. The only difference is the receiver type is a 3-component geophone, but the field operation is the same. Cost is always a concern in multi-component development. Of course, the cost of OBS survey is much higher than marine streamer survey, but marine streamer survey narrow estimates with only P wave measured. OBS survey are always wide estimates with long offsets and high density, and it can also imaging around the surface obstructions. With OBS data, we can get high quality wide estimates, P wave and converted wave conveniently. And due to the high folds, the quality of the data is good, and the signal to noise ratio is also good. And this is also very important for multi-component processing. And on top of it, we can extract more reliable rock property from the multi-component imaging for reservoir discovery as well. That's another big reason for the oil company interested in OBS and MC technology.
Sure, I'm sure companies are perking up when you're saying there's no additional cost, really. Yeah, you mentioned earlier that your talk is also going to address challenges. What are a couple of challenges in multi-component processing that you're going to highlight in this talk?
Yeah, there are lots of challenges in multi-component and OBS processing. And I will emphasize some of the main challenges in the converted wave imaging. And I think the most critical challenge is shallow velocity, S-wave velocity model building, because that in the shallow, the VS can be very, very slow, and which will result in very large shear statics and a highly distorted C-wave imaging. And for the depth model building point of view, the shallow model is always important because it's always building the shallow model in the beginning, then go to the deep part. Without the correct shallow model, it is very difficult to build a deep model correctly. Another main challenge is shear wave splitting, which is resulted by the azimuthal anisotropy. And we always observed shear wave splitting in many multi-component survey. Since it can cause a signal missing in the radio component, it's split into the transverse component. So we need to bring them back. Another important challenge is that velocity model building for both VP and VS. Because if you want to get a good PS imaging, it is very important to build a correct model. So this is the three main challenges I will discuss in my talk.
Have advancements in converted wave imaging help address some of these challenges you just talked about?
Yeah, as I mentioned, in a shallow velocity model is very important. Surface wave inversion to build a shallow velocity model and solve that shear statics is the most recent advancement. And like the P-wave data, we have a first break recorded, and we can use them to derive the shallow P-wave velocity. But there's no shear wave first break. And surface wave carry on shallow information provided a very useful alternative for shallow velocity model building. When we use the multi-mode surface wave inversion, the results will be more robust and reliable. And we combine it with the enhanced surface wave dispersion analysis and automatic dispersion curve picking. The method becomes more durable for large-scale commercial projects to deal with complicated shallow geology and heterogeneity. This method has been applied in many OBS surveys successfully in both Asia Pacific and in Europe.
Does your talk itself just explore case studies involving ocean bottom seismic acquisition?
No, I will describe some basic principles and important concepts used in converted wave processing, as well as some case examples from both land and OBS service.
We were talking a little bit about converted wave imaging, and can converted wave imaging support the discovery of potential hydrocarbon prospects in certain basins?
Certainly, because in some basin like Malaysia basin and offshore Indonesia, there are serious gas cloud problem, especially in the shallow. So the P wave imaging was highly disturbed or contaminated. So using the C wave, converted wave, it can image through the gas cloud. So we can get very nice imaging underneath the gas cloud. And the quality of PS imaging is much higher than the P wave imaging. Based on that, we can give a good interpretation. We had such case study in offshore Indonesia Bekaba Basin, and it will help get a correct structure interpretation, because the P wave with gas cloud and cause the distortion and some structure false fractures. But PS doesn't have those problem. So it's give a very good interpretation, hope the discovery of that hydrocarbon and hydrocarbon discovery, and also better reservoir characterization.
You state in your summary of the talk that utilizing multi-component technology is like moving from black and white images to color. Why does this technology make such an impact on hydrocarbon exploration?
This is an analog, and from the imaging point of the view, P-wave imaging is actually not completed, because the seismic wave propagating in Earth is in a vector format. With P-wave measured only from the vertical component, the imaging is not completed. And another point is the rock property extracted from the P wave only may be missing or have less information delivered due to a P wave converted wave may contain actual information of rock property, which will be very helpful for identify potential reservoirs. For example, using the C wave inversion, we can get a better VP-VS ratio more reliably, which can be used as a tool to help identify fluid type. With increase in hydrocarbon saturation, the P-wave velocity will decrease, while the S-wave velocity remains relatively unchanged. So the VP-VS ratio can indicate different fluid content. And PP and PS amplitude ratio map can also acting as an indicator of important lithology changes as well. So adding all those information to the data, I think it's just like painting color to a black-white pictures.
Yeah, that's a good parallel there. And it was answered a little bit, I think, in the previous question. But what are some of the structures that were previously unseen in P-wave images that through multi-component technology geophysicists are now able to see?
This is due to different PPPS impedance contrast to different interface with different lithology, mineralogy, and porosity conditions. P-wave may be transparent to some reflectors, but PS impedance contrast is much higher on those interface. That's why people cannot see them in the P-wave imaging, because pretty weak impedance contrast. But we can see them in the PS imaging. I saw such a phenomenon in many surveys. For example, we found from BP Tangguh OBN survey, a sand body was never seen before in the P-wave imaging, because there's no strong refraction response, but was observed in the PS imaging.
You're sharing a lot of valuable information and giving a great overview of this talk. What do you hope at the end of the day will be the takeaways or a couple of the takeaways for attendees of this talk?
I often hear people suspicious about the value of multi-component technique and questioning the efforts invested and the reward. So I hope people, after hearing my talk, to gain more confidence on the multi-component imaging and understand that even though there are lots of challenges in the multi-component and OBS processing, but we have actually overcome the major difficulties. And with the OBS technology, we can obtain higher quality multi-component data and produce very nice PS imaging. But the cost is not much higher. And especially I hope people know in that gas cloud area where the PS wave imaging are always superior than the P wave imaging. And multi-component imaging will also help to discover potential reservoirs where are not detected, which are not detected in the P-wave imaging, but due to different PS impedance contrast, we can detect them in the PS imaging.
If you would, please finish this sentence. When the industry better embraces multi-component processing, it will...
I like to say it will for sure learn us to see more completed and real imaging of the Earth to help us improve hydrocarbon discovery.
That is wonderful. And kind of lastly here, a little separate from your talk, but you're doing some amazing work and providing this great talk on behalf of anyone at SEG interested in this talk. What is one piece of advice you would offer someone that would like to succeed as a geophysicist?
Yeah, as I mentioned what I want to take away from the audience, I just wanted to because people always hesitating to acquire the multi-components. Even in the OBC survey, they already have the multi-component data, but they don't process it because it's 3 components. So it's in the acquisition, it's received both horizontal and vertical component, but they are not processing it. So I think this is a big loss because there are lots of information in there. Acquisition already spent a lot of money, and the processing is just a very small amount. It will bring huge benefits, not just from rock properties extracted from that PPPS data jointly, and also that the gas clouds images.
Well, that is, you've provided a great summary of your talk, and I'm sure gotten people excited. I appreciate your time and speaking with me today on this, and for taking the time to make this great lecture that people are going to be able to benefit from.
Thank you so much, and for your guidance and spend time to give this conversation with me.
Thank you for listening to SEG's flagship podcast, Seismic Sound Off. SEG produces these episodes to benefit its members, the geophysics community, and inform the public on the value of the science. To show your support for the show, please share this episode with a friend, colleague, or manager that would enjoy hearing this show. Your recommendation is the single best action you can take on behalf of SEG's podcast. Go to the website at seg.org/podcast to find all the episodes and learn how you can subscribe for free directly on your phone. Original music by Zach Bridges. This episode was hosted, edited, and produced by Andrew Gary at 51 Features. The SEG podcast team is Ted Bakamjian, Jennifer Crockett, Allie McGinnis, and Mick Sweeney. Thank you for listening. This is Seismic Sound Off, signaling off.